Okay, so here's our lesson on rate of change and slope, and you know how to find those things. So part of what I'm going to be doing today is just reminding you how to find rate of change and slope, but really we want to focus on how to interpret rate of change and slope, and we're going to talk about comparing those also. So rate of change, really the big formula that you need to know is that rate of change is the change in y over the change in x. And I want you to note that sometimes that will be written with a Greek letter called delta. So sometimes when you see it, it's going to look like this. That means that triangle is delta. So that's change in y over change in x. There are a few other formulas that we'll talk about today, and so we can go ahead and write those down so they're all together. The other one is going to be rise over run. And then we have one that's y2 minus y1 over x2 minus x1. So all of these we might end up using today. All three of those, I guess, are for rate of change, and then we'll define really what slope is and how that's different here in just a minute. Okay, so we are going to spend a minute looking at some of these examples and really spending some time on context and on comparing. So the first thing I want to do is find the different rates of change for this table. So I'm going to focus just on these first 2 years right here. And remember, we want to do change in y over change in x. So first of all, I'm going to note that this is from 2003 to 2004. 2003 to 2004, that's what I'm talking about here. I want to do the change in y over the change in x. So the change in y from 37 to 37, all I'm doing is, it's not increasing or decreasing, that's just 0. So we're going to have 0 cents, and actually I'm going to put a plus sign just so that we can think about what's happening there. And then on the x part, we are going up 1. So it's change in y, so adding 0 cents over 1 year. Well, 0 divided by 1 is just 0. So if I were to interpret that, that would be an increase of 0 cents per year. That's how you read that. All right, that one was pretty easy. Let's try another one. All right, this time I'm going to do 2004 to 2006. And if I look, this time I have an additional 2 cents over a period of 2 years. Well, when we do rate of change or slope, we always want to simplify that. So when I simplify that, I'm going to get an increase of 1 cent per year. All right, because you want to divide 2 divided by 2. All right, we'll go again from 2006 to 2008. All right, that is going to give us, in my y coordinates, I'm increasing now by 3, so a change of 3 cents in 2 years. All right, 6 to 8 is 2 years. So when I simplify that or interpret, that's going to mean an increase, we'll write that in words, increase of 3 divided by 2 is 1.5, so an increase of 1.5 cents per year. All right, one more left to go right here at the end. So that's going to be 2008 to 2013. If I look, I've got an increase of 4 cents, and that's over a span of 5 years. And if I simplify that, I'm going to get 0.8 cents, or rather an increase of 0.8 cents per year. So when we go back and look at those and we try to compare and make some statements about those, you should notice that, let's see, we want to notice that in the first year there was no change, right? That's a 0 cents per year. In between 2006 and 2008, that was the greatest increase because it increased 1.5 cents per year as opposed to only a cent or even a part of a cent. So just know, in this case, because all of the rates of change are different, this would be an example of something that is non-linear. Now, you would not do all of this work for one problem just to say it's nonlinear. I'm showing you like 3 or 4 different skills at one time. So being able to find the rates of change just by looking at a table, that's a skill. Being able to interpret it using context or using units, that's another skill. Being able to compare them to find the steepest part, that's another skill. And being able to determine if it's linear or nonlinear, that's one of our last skills. All right, so the only real difference between slope and rate of change is that slope is when you have lines. So slope is only a word used when you're speaking about something that is linear. The reason that we use rise over run, think about you're talking about your change in y values, and y is what goes up or down, and x is what goes left to right. So rising is your up and down action, and running is your left to right. So you just want to make sure that you get those in the correct order when you count. The other thing that we need to be paying attention to, so we'll do an example here together, but the other thing that you need to pay attention to is what the graph is counting by. Remember, a lot of times the graphs in our book count by 2's, so we have to keep that in mind when we go to calculate slopes. So here's a quick little example for us when it comes to a graph. You first need to find 2 points. If they don't give you 2 points, you want 2 that are in a spot where you know the exact values. So this is not like the best example, but I'll show you kind of some better ones in class. All right, but we want to have these specific, we're going to use those specific values. And then sometimes people aren't sure like which point to start with, but if you like write your name or a word or anything on the line, whichever point the word starts on, that's where you need to start. So, for example, I started writing the word slope above this first point, -2, 3 right here. So that's where I'm going to start counting my slope. And remember, the formula is rise over run, where that's a little strange here, because if I start right here, I can't really rise anywhere, right? Rising is making me move away from the line. So instead, my rise is going to be negative. And pay attention, that's on 3. It may help you to like make marks in between. So this is down 1, 2, 3, which means my rise is -3. And then I'm going to run to try to hit this other point. And my run is also 1, 2, 3. So my run is 3, which makes my slope -3 over 3, or if we simplify that, -1. Now, the reason that this is a negative slope is because remember, if you write your name or if you write a word, this line goes down, right? This word negative that I just wrote on the line is facing downwards. So that's going to be an example of a negative slope. Just so that you have a quick little sketch in your graph to compare that, if you had a slope that was from left to right was moving upwards, that would be an example of a positive slope. And notice when I write a word on top of the line this time, the word is moving upwards instead of downwards. All right, so the last 2 things that we need to discuss are about horizontal and vertical lines. So if we look at a horizontal line here, horizontal would be a line that just goes, think about horizon, right? It's going to run left to right. So if I try to do rise over run here, if I pick 2 points, and I try to do rise over run, rise, I'm not going to rise neither up nor down, right? I'm not moving anywhere there. So my rise is 0, and then my run is, it doesn't even really matter how far you run. Like you could run an infinite amount, you could run 1, 2, 3, that doesn't matter. So any number could be the run. Because it doesn't matter, any time you divide 0 by a number, you're still going to get 0. So this is an example. In your notes, you should probably have a horizontal line drawn, and you should tell yourself that that's going to be an example of 0 slope. All right, vertical lines are a little bit different. So vertical are something that goes straight up and down. And now if I do rise, well, I could rise an infinite amount. So when I write this out, I've got my rise could be infinite, or we could pick a number if you want to, 2. And then my run, I'm not running any, Well, that's 0. And hopefully you know this, but if you don't, you can ask your calculator and it will tell you. You can never divide anything by 0. Your calculator should tell you error. So because the 0 is on the bottom, this is an example of what we called being an undefined slope. So the line that goes straight up and down, you need to have marked as being an undefined slope. Another way to think about that, I had a teacher once that told me you can't ride your bicycle straight up a hill or a cliff, right? You can't ride your bicycle this way, so it's undefined. You could ride your bicycle on flat ground, and that takes like 0 effort. So that's another way to kind of think about that. I think I've also had kids that said the word Z or the letter Z makes a 0 slope. So think about if I draw the letter Z, I've got 2 0 slopes here. That's whatever you need to do to remember, but you do need to know the difference between 0 and undefined.